Hello everyone from the world of industrial automation. My name is Artem Melnik, and I am a software engineer with 15 years of experience in developing firmware and software for programmable logic controllers and integrating code sys runtime into these firmwares. On this YouTube channel, I will be creating a prototype of an automated control system based on CODESYS. And together with the viewers, we will bring this prototype up to an industrial level. Step by step, we will work with you to identify and fix the shortcomings of this prototype, as well as integrate the solutions you suggest for the problems we encounter along the way. But the main goal of this channel is to teach how to work with CODESYS, using real-world examples of automated control systems, not with a virtual PLC, but with an actual controller and other industrial equipment from Occitech. Let's develop an automated control system for an industrial dry heat sterilizer, which is used to disinfect metal instruments, for example, in the medical or beauty industries. Not all controller manufacturers with the CODESYS environment have a license for web visualization, but the controller from Occitech comes with such a license. This means the user doesn't need to purchase it separately or perform additional, often complicated steps to activate it. Web visualization allows you to control the automated system using any device with a browser, including your smartphone. All the mentioned devices are connected to each other through a router that has internet access, and this will allow us to demonstrate how web visualization works, as well as connect the SPC210 controller to the Occitech cloud service. This template, developed by Occitech, frees the user from needing to know what Modbus is, meaning you don't have to spend time studying the documentation. The modules register map, and you won't have to worry about how to properly configure a bunch of parameters to form requests or rearrange registers to get correct data and convert them to the required types. When you purchase any device from Occitech, the cloud service is completely free. Before we dive into the algorithm, I'd like to ask, did you notice that my voice has changed? The thing is, I want to pick the best voice for you using AI. Please write in the comments which voice you like the most and which one you think is my real voice. Now, let's break down the sterilizer control algorithm. The first condition is converting milliamps to degrees Celsius. But this block of code is commented out because the analog input module from Occitech handles this task for us. The next block of conditions is responsible for starting and stopping the sterilizer operation. If the start button is pressed, that is, the variable's value is true, and the sterilizer is in the off state, then we turn on the heater. In other words, we set this variable to true and switch the sterilizer to the heating state. But if the stop button for the sterilizer is pressed, that is, the variable's value is false. And if at the same time the sterilizer is not in the off state, then we turn off the heater and switch the sterilizer to the cooling state. Write in the comments why this expression is unnecessary here. The next block of conditions is a case statement, which is a variation of the if statement. The first condition of the case statement: if the sterilizer is in the heating state, then we check the next condition. If the current temperature is greater than or equal to the holding temperature, then we switch the sterilizer to the temperature holding state and start the timer for the number of minutes set by the user. Write in the comments why I multiply the number of minutes by a constant and why this expression is unnecessary here. The second condition of the case statement: if the sterilizer is in the temperature holding state, then we check the next condition. If the current temperature is below the lower hysteresis limit relative to the holding temperature, then we turn on the heater. And if it is above the upper limit, we turn it off. Next, we call the timer to keep it running. And if the temperature holding time has ended, we turn off the heater and switch the sterilizer to the cooling state, and also turn off the timer. The third condition of the case statement. If the sterilizer is in the cooling state, then we check the following condition. If the current temperature is less than or equal to the safe temperature, we switch the sterilizer to the off state. And we turn off the start-stop button indicator for the sterilizer, as well as turn off the timer. Write in the comments why we turn it off. The next block of conditions. If the current temperature is higher than the safe temperature, we turn on the indicator light for exceeding the safe temperature. Otherwise, we turn off this indicator. Write in the comments how you could shorten this block of code to a single line. The next block of conditions is, this is an improvement to our prototype. If the current temperature exceeds the maximum temperature limit set at 190 degrees, we turn off the heater and switch the sterilizer to cooling mode. And we also set the alarm variable to true, which we send to the Accu-Tech cloud service. Write in the comments why this improvement is necessary and why we send this alarm to the cloud and why we use read-write access for it. The next block of conditions is responsible for selecting the main relay and calculating the current number of activations. If the auto-switching mode is enabled and the current number of relay activations exceeds its maximum allowed number, that is, its resource, then we swap the roles of the main and backup relays. If the switching is done manually and the user has set the first relay as the main one, then we select it as the main relay accordingly. If the user has set the second relay as the main one, then we make the second relay the main relay. Next, we increment the current relay activation counter and set the previous heater state to the current state so that this block only executes at the moment the heater is turned on. Write in the comments what purposes the operator might use this functionality for. The last block of conditions. If the first relay is the main one, then we set the signal value of the first relay to the current value of the heater. If the second relay is the main one, then we set the signal value of the second relay to the current value of the heater. Write in the comments what exactly is missing in this block. Let's move on to the second topic. Analyzing the visualization components of the sterilizer. The first component is a rectangle. To enter new values, we'll set up a click event handler and select the function to handle this event. Writing to a variable. In the input type field, select the VisuDialogs.numpad dialog, or simply put, the numeric keypad window. Set the minimum value field to 0, so the user can't enter a negative value. The other components for entering new sterilizer settings are configured in the same way. The second element is a combo box. For this element, we previously created a text list with the following values listed in the ID column and the default column, which correspond to the main relay selection mode. In the element settings, in the text list field, select our text list, and in the variable field, select our variable for the main relay selection mode. In the value range field, set the minimum and maximum values. The next component is the power switch. In the variable field, select our variable for the sterilizer start and stop button. And in the background field, select the green indicator color. The next component is the lamp. In the variable field, select our variable responsible for turning the safe temperature indicator on and off. And in the background field, select the red indicator color. To display the current state and temperature of the sterilizer, we use rectangle components. But for these, we do not set up click event handling for user input of new values. And the last component is the bar display. In the value field, select the variable for the current temperature of the sterilizer. And in the scale start and scale end fields, select the minimum and maximum values for this temperature. In the main scale field, set the value to 10, which will create 20 main divisions on the element. In the subscale field, set the value to 5, which will create one additional division between every two main divisions. Let us know in the comments which visualization components for the sterilizer you would add or edit. In the next video, we'll answer the question of how we ended up in the middle of the CodeSys project. And for that, we'll go back to the very beginning. We'll also start breaking down the CodeSys simulator project, which we'll need to improve the sterilizer prototype. And we'll also launch a surprise segment where we'll cover a topic that wasn't announced in the previous video. Let us know in the comments what you'd like to see in the surprise segment. And who knows, maybe we'll cover your topic specifically. Now, I'd like you to point out any flaws you've noticed and suggest ways to fix them. We're also looking forward to your suggestions on how to improve the sterilizer algorithm. For example, you might suggest replacing the current temperature control method with a more precise one, like PID control. I'm also offering you a choice of the following training video topics, which I've pinned on the channel. How can you use the built-in OPC UA protocol server in CodeSys to integrate the SPC 210 into popular automation platforms from well-known companies? How can you use the built-in cybersecurity tools in SPC 210 to protect against hacker attacks? How can you increase the response speed of SPC 210 and the input-output modules pulled via the Modbus TCP and Modbus RTU protocols in CodeSys? What are the advantages and disadvantages of the Modbus master and slave modes of the WineTech operator panel when used together with SPC 210? What are the advantages and disadvantages of multitasking in CodeSys? How can you use the visualization editor in CodeSys to create a multilingual project and set up screen navigation? How can you use the built-in Linux utility call library in CodeSys to integrate SPC 210 with popular automation platforms from well-known companies or with any specialized applications? How can you use the built-in Akitech communication library in CodeSys to bypass the limitations of standard Modbus components? Let us know in the comments which of these topics interests you most, or suggest your own. Also, if you want to learn CodeSys on real industrial equipment, our channel has the exclusive right to offer a promo code for a 35% discount on the purchase of SPC 210 and I/O modules from Akitech. To get this promo code, just follow the link below to our WhatsApp or Telegram channel. And in the channel profile, you'll find my personal contact, where you can send me a direct message with the promo code. But I want to point out that this promo code is only valid for 24 hours. So, please write only if you have already added the products to your cart on the Akitech website. And here's another nice surprise for those viewers who buy the SPC 210 and send me the serial number of their controller in a private message. I'll give you all the CodeSys projects used in our channel's videos for free. You can also subscribe to our WhatsApp and Telegram channels so you don't miss announcements about upcoming videos. And of course, so you can always get a promo code for a discount on Akitech products. And don't forget to subscribe to our YouTube channel, so you don't miss our next videos And also, give us a like if you enjoyed this video. That's all for now. See you in the next videos.